Now, what wonderful thing happens a week from Monday? What wonderful thing happens a week from Monday, as far as my class is concerned?
You go back in person.
We go back in person. We come back in person. So you're going to be back with me in the classroom. Again, we're going to have to be hybrid. We're going to have to be hybrid. I mean, so it's kind of like a nightmare. I kind of feel like I'm teaching in Vietnam right now. That's what I feel like. You're learning in Vietnam and I'm teaching in Vietnam. And we never know what we're going to do every day. We never know what we're going to do every day. But we're going to soldier on and we're going to get through. I am trying to get a bigger classroom for one of the days. There's less classes on Friday, so I'm hoping to get a big classroom so that all of us can be at least in the classroom together 2 days out of the 3 days. 2 days out of the 3 days. Because I think that will help you, and it will help me as far as being able to speed up. I've been trying to keep things at a little bit more of a modest pace because, to be honest, I don't think I could learn the way you guys are learning. I don't think I could learn from Zoom. I mean, you're coming to my lecture, you can barely see the board, you're squinting to see stuff, you have me, which is hard, ADD, and you're learning from Zoom. If I was in my room and trying to look at a camera, trying to look at my screen, and a teacher was talking, anything that would walk by, I would be immediately distracted and not be able to focus. Anything, just cat. Oh, cat, cat, cat. Anything. Okay, I'm going to get your brains going. We're going to have our second quest, write this down, we're going to have our second quest next Friday. We're going to have our second quest next Friday. It's going to be on the cross product and lines. It's going to be on the cross product and lines. So it's going to be on 12.4 and part of 12.5. 12.4 and part of 12.5. Your homework for tonight is to finish 12.4 and to read 12.5. What did I just say?
Finish 12.4 and read 12.5.
Finish 12.4 and read 12.5. We have what next Friday? Quest 2. Okay, let's get your brains going and help you get ready for the quest. How many people now know that somebody who doesn't have their flashcards memorized is at a great disadvantage in comparison to somebody who does has their flashcard? How many people recognize that? You should have almost all of your cross-product flashcards, not memorized, but written. You should have almost all your... I'll give you a specific number. I'll figure out exactly what number. Okay. To help you with that, I've got these things here. I will read them off. And what I'm going to want you to do is to answer these. I want you to answer these. I'll read them off, and I want you to answer them. Okay. The cross product, A cross B, is a vector. It has 3 components. What are those 3 components? A cross B, without looking at your notes, is equal to a vector. Without saying anything, just write down your answer. What are those 3 components in that cross product vector? Because you're going to want to own this by next Friday. Without looking at your notes. Okay, number two. You should have it down to be able to do it that fast. That's the rhythm, that's the tempo I want you to be able to calculate one of these cross products. If 2 vectors cross product is the 0 vector, if 2 vectors cross products is the 0 vector, what does that imply about the 2 vectors A and B? If 2 vectors cross product is 0, what does that imply about your two vectors A and B? Number three. A cross a scalar multiple of A. A cross a scalar multiple of A. What vector will that equal? What vector will that equal? If you have A cross a scalar multiple of A, what vector will that equal? Number 4. B cross A is equal to what other vector? B cross A is equivalent to what other vector? Write it down. B cross A is equivalent to what other vector? Oh yeah, and emotionally get yourself prepared to get back your handwritten part on Friday. I'm passing that back. I'm passing that back in class on Friday. I'm passing back your handwritten part on Friday. This Friday. Number 5. The scalar alpha times the cross product vector, A cross B, is equal to what other two forms of vector and scalar multiplication? The scalar alpha times the vector A cross B is equal to what other two forms of a scalar and vector multiplication? Write it down. Okay, number 6. If you have the head-tail rule and you're doing the vector B plus C, if you have the head-tail rule and you're doing the vector B plus C, and then you're going to do A cross B plus C, that's equivalent to doing what else? How else could you find the vector A cross B plus C? How else could you find the vector A cross B plus C? Number 7. Lagrange's identity. Without looking at your nose. The norm of A cross B squared is equal to what other identity? The norm of A cross B squared, according to Lagrange, is equal to what other identity? Number 8. You have the vector A dotted with the vector A cross B. You have the vector A dotted with the vector A cross B. What scalar is that equal to? What scalar is that equal to? A dot A cross B. And similarly, number 9, B dot A cross B. And for whatever you wrote down, what does that imply about the vector A and A cross B and the vector B and B cross A cross B? What does that imply geometrically about the vectors A and A cross B and B and A cross B? If C dot A cross B is the scalar 0, if C dot A cross B is the scalar 0, what does that tell you geometrically about these three vectors? If C dot A cross B is 0, what does that tell you geometrically about these three vectors in three-dimensional space? If number 11, if C dot A cross B is a negative number, if C dot A cross B is a negative number, what kind of orientation does that imply about the vectors A, B, and C? If C dot A cross B is a negative number, what does that tell you about the orientation of the vectors A, B, and C in three-dimensional space? Number 12. Since C dot A cross B is a scalar, this is absolute value. This is not norm. This is absolute value. It's not norm. Geometrically, what does the absolute value of C dot A cross B represent geometrically? What does the absolute value of C dot A cross B represent geometrically? And again, all I'm doing is helping you guys get ready for Quest 2. Number 13. I've written down the norm of A cross B. The norm of A cross B. A cross B is a vector. I'm taking the norm of that. Geometrically, what does that represent? Geometrically, what does the norm of A cross B represent? Write it down. Write it down. Get those cameras on because you guys are going to breakout groups and you're sharing what you have with other people. and you guys should be sharing with each other. You guys should be sharing with each other right now. I guess I could share with you. I could share with you. So you videoers, this is it. What does the norm of A cross B represent? What does the norm of A cross B represent? You know, like Dr. Warren, there's a big breakout. The norm of A cross B represents the area of the parallelogram described by A and B. So you can see it right here. You can see it right here. We have this parallelogram, okay? And I wonder how much area is there in the parallelogram where I've got a B and I've got my A, and I've got a copy of B, and I've got a copy of A. Well, it's the norm of A cross B. That's what we've argued in this class. 12 represents the volume of the parallelepiped, which you can see right here, We think of this as being the vector A, or maybe this as being the vector A, this as being the vector B, and this being the vector C. If we made copies of those, we would create this parallelepiped here, and that's what this represents. C dot A cross B represents. Okay, this one you probably don't remember. It means that they're negative. It means that, if it's negative, it means there's a left-handed orientation. It means that there's a left-handed orientation. Or if I've got the vectors A and B, that if it's negative, I've got a left-hand orientation, which means that C is going to fall beneath the plane that A and B is in. So it would be, I would have to do B cross A, it would lie in the same plane, would lie in the same space that B cross A is, not A cross B. If it's positive, it lies up here. If it's positive, it lies up here. Okay, so it would lie in the same plane as A cross B. Okay, now I'm going to bring everybody else back. Maybe I should give them a couple more minutes. So you may want to just pause this now. You may just want to pause it, and then when we come back, when we all come back, then we can just you can unpause it. All right, guys, all right. You're going to want to have these cold next Friday. You're going to want to have these down cold next Friday. Because again, somebody who does is going to be at a huge advantage over somebody who doesn't. These are all flashcards. These are all flashcards on that flashcard sheet that you guys are supposed to make. I'm not going to go over all of them, but I will pick a couple of them. The first one, what does the norm of A cross B represent geometrically? What does the norm of A cross B represent geometrically? The area of the parallelogram defined by A and B. The area of the parallelogram described by A and B. So for example, if you look up here, I've got a vector A, I've got a vector B. If I made copies of these vectors, if I moved B up here and I moved A over there, I would get this parallelogram. What does this number represent? If you take the cross product and you take the norm of that vector, what does it represent again?
The area.
The area. So this is the area of the parallelogram. Again, that's a flashcard. Okay, number 12, C dot A cross B. What does that number represent geometrically?
Is it the volume of a parallelepiped?
Very good, Mason. It is the volume of the parallelepiped described by these three vectors. And I've got, in fact, a parallelepiped right here. I've got a parallelepiped right here. This would be like the vector A. This front edge would be the vector A. This side edge would be the vector B. And this thing coming off of that plane, this would be the vector C. Now imagine that I made copies of C everywhere, on every corner. So there'd be a C here, there'd be a C over here, and there would be a C here. And then I made a copy of this plane and put it on top. And I asked, what's the volume of this shape sitting in three-dimensional space? That seems impossible. How could you ever calculate that? And yet, all you have to do is take the
Cross product.
cross product and the dot product and take the absolute value of that number, and that's the volume, Okay. What if C dot A cross B equals 0? What if you have C dot A cross B? You've got three vectors. You do A cross B and you dot it with C, and you get the number 0. What does that tell you geometrically about these three vectors? They all lay in the same plane. They all lay in the same plane. Like, for example, I've got three vectors. I've got my B and my A and my C. Imagine the parallelepiped that's coming from this. You're like, Dr. Warren, I can't visualize it. Imagine that I created, will there be volume? Would there be volume? If I created a parallelepiped, would there be volume?
Yes.
And what if I'm down here? What if I'm down here? Would there be volume of that parallelepiped? And you're like, yeah, you got. The only way you're going to get 0 volume is if all three of your vectors lie in the same plane. The only way you're going to get 0 volume is if all of your vectors lie in the same plane. So I could ask on the quest, do these three vectors lie in the same plane? And you'd be like, holy hell, Dr. Warren, how am I supposed to determine that? Oh, well, somebody who knows their flashcards, are going to be at a great advantage because they're going to go, let's do C dot A cross B. If it's zero, they lie in the same plane. If it's positive, we say they have a right-handed orientation. If it's positive, we say they have a right-handed orientation, A, B, and C. If it's negative, they have a left-handed orientation. Now let me explain again what that means. Imagine that I've got a vector A coming out of the board, and I've got a vector B going into the board. Draw the vector A cross B. I've got a vector A coming out of the board, and I've got a vector B going into the board. Draw the vector A cross B. Okay, by number 8 and number 9, let's see what you got. What is A dot A cross B equal to? What did you get for 8 and what did you get for 9? What did you get for 8 and what did you get for 9? What did you guys get for 8 and 9? Nothing? You wrote nothing down. What did you write down? What did you get for 8 and 9? Anyone? 0. What does that tell you about the vector A and the vector A cross B? What does that tell you about the vector A and the A cross B?
Orthogonal.
They're orthogonal. They're perpendicular to each other. So I'm hoping everybody drew a vector that went straight up. Show me what you drew. Hold it up to the screen. I want to see what you drew. Excellent, excellent, excellent. Okay, perfect. So by property 8 and 9, I know this is going to lie at a right angle here, and this is going to lie at a right angle in the one going back. I know no matter what I say, you're not going to focus, so I'm going to... Araya! Okay, you be gorillas with me. Come on, gorilla, gorilla. Robert, gorilla, go, whoa! Oh, go count 3, count 3, count 3. Okay, I think that's good. I think that's good. Draw a vector C. Draw any other vector C in your three-dimensional space. Put its butt at the origin. Draw any other vector C. Draw any other vector C with its butt at the origin in that drawing that we have there with our A across B and B. Draw a vector C. Okay, now hold up what you've got. Hold up what you've got. Okay, I'm taking Caitlin's. I'm looking at Caitlin's. I'm grabbing, actually everybody's looks kind of the same. I'm grabbing Caitlin's. Caitlin's, I'm going to take your vector there. So I could ask this on the test. I could give you a drawing like that, and I could ask, do the vectors A, B, and C, the vectors you drew, do they have a right-handed orientation, a left-handed orientation, or a stupid question, do they all lie in the same plane? What's one thing you can rule out immediately? What's one thing you can rule out immediately? They don't lie in the same plane. Now the question is, do they have a right-handed orientation or a left-handed orientation? Take out your right hand. Take out your right hand. Take out your right hand. Now do A cross B. Do A cross B. Do A cross B. This vector lies above the plane. If I think about this plane as chopping my room into two parts, one part's up, the other part's down. Every plane cuts three-dimensional space into two distinct areas. Does the vector C lie in the same part as the cross product vector? Does the part vector C lie in the same half as the cross product A cross B? Does Caitlin's vector lie in the same half as the cross product vector? Then you have a right-handed orientation. And this C dot A cross B would be positive. C dot A cross B would be positive. Now, if nobody did, but imagine that you're down here. Imagine that you're down here. Then it doesn't lie on the same part as A cross B, which means that angle theta is going to be larger than pi over 2. And we'll end up with our negative. We'll end up with a negative value instead of a positive value. It lies in the part that's opposite, the half that's opposite our cross product vector. It's left-handed. Put out your left hand. Because if you swung A to B, it's going to lie on the same part of space as your thumb. Left-handed. Right-handed? Say it. Right-handed? Left-handed. Okay. Just, what's that component? There's 3 components in the cross product vector. What's that component? I only care about the last component. What's the last component in the cross product vector? What's the last component in A cross B? What's the last component? What is it? A1, B2 minus A2, B1. Minus A2, B1. You guys should own that. Okay. Without writing it down, what's Lagrange's identity? The norm of A cross B squared. This could easily be on the test. The norm of A cross B squared is equal to the norm of A cross B squared is equal to the norm of A squared times the norm of B squared minus A dot B squared. Minus A dot B squared. Okay. Does this help you? Does this help you get stuff memorized? Is this helping you begin to get stuff memorized? Okay, you're like, no, Dr. Moore, doesn't help me at all. Okay, stand up again, stand up again, stand up again. Okay, now what we're going to do is we're going to run in place and do gorilla. Run in place and do gorilla. Run in place and do gorilla. Okay, sit back down, sit back down. I can't wait for you to be back in the room with me doing gorilla and running in place. I guess we shouldn't breathe, but we could still do gorilla, not breathe, and run in place. Because I sound like a moron. I sound like a moron in Burris Hall. I'm the only person yelling and doing gorilla. People are out cleaning out there. They've removed half the desks. They're taking those away. Okay, and I'm doing gorilla. I'm doing gorilla to keep you awake. The things I do to keep you awake in class. The things I do. All right, now you're getting ready to make this calculation. You're getting ready to make this calculation next Friday. I give you 3 vectors. An A with a bunch of numbers, a B with a bunch of numbers, and a C with a bunch of numbers. And I say make that. There's a fast way to do it, and there's a slow way to do it. The slow way to do it is to take the cross product and then do the dot product. The fast way to do it is with the determinant. The fast way to do it is with the determinant. So if I have A cross B dot C, and I want to do it quickly, I put my first row as the thing I'm dotting. I put my first row as the thing I'm dotting. It's replacing the I, J, and K. It's replacing the I, J, and K in our other determinant for the cross product. The next thing I do is I put the vector that's in front for the cross product. My A1, A2, A3. And then I get my B1, B2, B3. Okay, now I'm going to give you 3 vectors. I'm going to give you 3 vectors, and I want you to calculate this quantity. Your vector A is 1, 1, 1. Your vector B is 2, 3, 1. And your vector C is -2, 0, -1. Calculate A cross B dot C right now. Calculate A cross B dot C right now. Okay, I'm hoping that on next Friday's quest you would be done. You're like, Dr. Warren, I'm not done. I'm hoping on next Friday's quest you'll be done. Now let me do it with you. Let me do it with you. Okay, so how many people filled in this determinant this way? How many people have those numbers in there? How many people have -2, 0, -1, 1, 1, 2, 3, 1? Okay. The first thing I do is I write down what was in the I location in my other determinant, which is the number -2. The first thing I do is write down -2. Now I cover that up. I cover that column up, and I just work with the bottom rows. I would do 1 times 1. Would it be positive or negative? Would it be positive or negative? Going down, would it be positive or negative? We're going that way. Positive. So we get 1 minus 3 times 1. 1 minus 3 is... 1 minus 3 is -2. So that's what would go there. Now I would write down what the next thing is, and it's going to have a minus in front of it. So it's going to be -0. The minus is because in my determinant, now I'm using the middle column, but these two columns aren't beside each other. You're like, well, Dr. Warren, the 0 is going to go away. I know it's going to go away, but I just want to make sure you guys know what to do. I would have 1 times 1, 1 times 1, minus 2 times 1. 1 times 1 minus 2 times 1. What would be the number that would go there? 1 times 1 minus 2 times 1. What would be the number that would go there, guys?
-1.
-1. Now I put the number that's down in the K position. Plus -1 plus -1. I cover up this. So you help me out. It would be -1 times
3 minus 2.
3 minus 2, which would just be 1. Or my final answer would be 4 minus 1, which is 3. Without even plotting the 3 vectors, what's the volume of the parallelepiped that would be described by these 3 vectors? What's the volume of the parallelepiped that would be described by these 3 vectors? Now those who have their flashcards are like, I know, Dr. Warren, I know. Well, I erased them. Which flashcard would you use? Which flashcard would you be using? Look at the numbers we had written down. Which flashcard would help you answer that question? Which flashcard would help you answer that question? Okay, and we just calculated, oh, you're like, wait, Dr. Warren, that's A cross B dot C. Is the dot product commutative? Is the dot product commutative? So this is the same thing as C dot A cross B. So the volume is 3. Are the 3 vectors in a plane? Do the 3 vectors lie in a plane? Do the 3 vectors lie in a single plane? Do the 3 vectors lie in a single plane? What do you say? What's your answer?
No.
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 Because this isn't 0. Do the 3 vectors have a right-handed orientation or a left-handed orientation? Do the 3 vectors have a right-handed orientation or a left-handed orientation?
Right.
Right-handed orientation. So like, for example, if you took the cross product, C would lie on the same side as the cross product vector. If you took A cross B, C would lie on the same part of 3-dimensional space as the cross product vector coming off that plane. How many people could see a question like that showing up on the test? How many people could see? I mean, how much information can you get out of this one number? I mean, just a ton. Okay, draw that circle. It's like the IJK. Draw that circle. This circle will save you. Draw A, B, C. Draw A, B, C, and draw the circle in the way the letters are going up in the alphabet. Okay. This is a little bogus what I'm going to say next because it's post Gibbs. It's post Gibbs. Gibbs didn't have matrices to work with. We're using determinants to find this number, but Gibbs didn't have matrices. But by properties of determinants, using properties of determinants, you're like, Dr. Warren, I don't know what a matrix is. Don't worry about it. I'm just giving you a justification. My justification for the next thing I'm going to write down is by properties of, what did I say? By properties of determinants, of matrices. We can prove the following identity. That this guy out of the way. That A cross B dot C, you get the same number if you do B cross C dot A. You get the exact same number if we use properties of determinants. You get the exact same value if you do B cross C dot A. I'm not using commutativity, guys. I'm not using the commutativity at all. The vectors are in different locations. And this is also equal to C cross A dot B. And you're like, well, Dr. Warren, how am I supposed to memorize that? Oh, we have the circle. So notice, if I start with the cross product, I've got A, B, A cross B, dot the third guy, C. And that gives me my first one. Now jump in the circle. B cross C dot A. And the only one left is C cross A dot B. So the circle, put a smiley face in the circle, because when you're studying for Quest 2, that will remind you, this helps you. This will remind you, this helps you. Because you'll be going, why did I write a circle in there? Because right now you're lobotomized. Right now, I've talked so much, you're lobotomized. Go to grid view. Anybody who can turn on their video, turn it on. Anybody who can turn on their video, turn it on. If you can turn it on, if I don't see a video, I'm believing you're actually not actually in class. You just turned your video on and then you're doing something else. You've gone somewhere. That's what I'm believing. If you haven't, okay, now go to grid view. Now look at those faces. Look at those faces. Do those faces look eager to learn to you? Look at those faces. Do those faces say, teach me, Dr. Warren? Now put your hands on the space bar. Put your hands on the space bar. And say what I just said. Now say it all together. Now Gordon, I didn't hear you say it, because I don't believe you want to hear me. Say it. Everybody together. Ready? Teach me, Dr. Warren. Teach me, Dr. Warren. I've got to learn this, Dr. Warren. Teach me, Dr. Warren. Okay, good. Now make me number one again. You know, oh, I get it. It's a lot. I get it. There's so much to memorize. But think about how freaking cool it is. You got these vectors flying around in three-dimensional space, any orientation you want. There's 3 of them. And you're going to find the volume of a parallelepiped. You're going to determine which direction they're going. You're going to determine if there are forces, whether you're going to get a right-handed screw or a left-handed screw orientation. And you know what the sad thing is? We haven't done any calculus. Because calculus is about limits, derivatives, and integrals. Oh my, like Wizard of Oz. Limits and derivatives and integrals. Oh my. We haven't seen a limit or an integral or a derivative all semester long. We haven't talked about functions, vector valued functions. What evil is this, Dr. Warren, you speak of? That's where we're going. We have 2 more vector cross product. English now comes. We have 2 more vector cross product identities. And then I'm going to let you go. We have 2 more vector cross product identities, and then I'm going to let you go. On Friday, we're going to start lines, planes, and trains. Lines, planes, and trains. I'm lying about the trains. I'd like to have a train, but we're not going to talk about trains. Lines and planes, lines and planes. That's section 12.5. Read 12.5, read 12.5. Okay, 2 more identities, and then I'm going to let you go. This next one you can't get except by doing components. But it comes from Hamilton, who didn't need to use components because he had the quaternions. But there's no way you can get this next identity using anything but components doing Gibbs's vector calculus. So let me give you the identity. You have a vector B cross C. You have a vector B cross C. So there's 2 vectors. I got my vector B and my vector C. Draw the vector B cross C. Draw the vector B cross C. I gave you a vector B, and I gave you a vector C. Draw the vector B cross C. Now draw a third vector A. Draw a third vector A with its butt at 0. With its butt at 0, 0, 0, at the origin also. Draw another vector A with its tail where the other 2 tails are. So now you should have a cross product vector. Now you should have a cross product vector B cross C, and you should have A. Hold up what you have. Hold up what you have. Let me see what you've got. Let me see your drawing. Let me see your drawing here. Okay, a lot of them look alike. Good. A lot of them look alike. Excellent. Excellent. Okay, now I'm going to blow your mind. What if I took the cross product of that new vector A with that vector B cross C that you've got? Try to draw that. Try to draw that. The vector A cross B cross C. Okay, hold it up again. Hold it up again. Now you're like, Dr. Warren, I'm not as confident. Dr. Warren, I'm not as confident. Let me see what you've got. Let me see what you've got. You guys are good. Yeah, Rhett, I like your drawing. Okay, guys, okay. Everybody owns this now. This is the vector, this is the vector, this is the vector, this is the vector, B cross C. And most of you drew your other vectors kind of like I would have. the vector A like this, the vector A like this. Now imagine that I've got a flashlight. This will just help us visually. Imagine that I got a flashlight and I'm shining this down. I'm shining this down onto here, okay? I can imagine that this kind of sits in the plane. If I'm thinking about this, this kind of sits in the plane down here like this. This would be like kind of at a right angle to try to give myself some idea where this vector's sitting in my space. So say this, the cross product vector is always perpendicular to the two vectors you're taking the cross product of.
The cross product vector is always perpendicular to the vector you're taking the product of.
Okay, that was really close. The cross product vector is always perpendicular to the two vectors you're taking the cross product of.
Cross product vector is
I mean, I've got my vector, I'm conducting now. I'm conducting Calc 3 with vectors.
the cross product vector is always perpendicular to the two vectors you're taking the product of.
Okay, so good. So like for example, you guys are pretty comfortable that B cross C is perpendicular to both B and C. Well, A cross B cross C would be perpendicular to what two vectors? A cross B cross C, that resulting vector would be perpendicular to what two vectors?
Vector A and B cross C.
A and B cross C. It's going to be perpendicular to both A and B cross C. Now I've got my plane, I've got this thing here, Let's just imagine that this is the vector. Imagine this is B, this is C. This is B, this is C, this would be, if this is B, this is C, this would be
Cross C.
B cross C. Now I want you to think about any other vector that's perpendicular to B cross C. I want any other vector that's perpendicular to B cross C. How does it sit in three-dimensional space? How does it sit here in the classroom? I want to think of any other vector that would lie perpendicular to B cross C. How would it sit in orientation here? We're like, would that work? Would that work? Would that be a vector that's perpendicular to B cross C? You're like, no, Dr. Horn, it's got to be perpendicular, damn it. It's got to be perpendicular. It's got to lie like this. But a vector is a vector anywhere, as long as the orientation and the direction is the same. So let's move it down to the plane that B and C are in. So this vector, and this is kind of what Rhett drew, this vector also lies in our plane. This vector also lies in our plane that B and C lie in. So that's the first thing. It's going to be in the same plane as B and C, but it's also perpendicular to A. It's also perpendicular to A, so it's going to be in the plane but it's going to be perpendicular to the projection of A down here in the plane. It's going to be in the plane, but perpendicular to the projection. So I could ask this on the test. Is A cross B cross C, would that be a vector that would lie in the plane of B and C? What would your answer be? What would your answer be?
Yes.
Yes. Now imagine I give you three vectors. How happy are you if I ask you to calculate A cross B cross C? You're like, Dr. Warren, you're going to have a timed freaking test, and you're going to give me three vectors, and you're going to ask me to first of all take the cross product of B and C, and then you're going to ask me to take the cross product of that vector with A. How many people might be pissed? How many people might be a little pissed at that point in time? Okay, so let me show you an identity that we can show is equivalent to this. show that this vector is equivalent to this. And I'm gonna, sorry, English is coming. It's equivalent to A dot C times B. A dot C times B minus A dot B times C. It's equivalent to A dot C times B minus A dot B times C. You're like, okay, Dr. Warren, that looks bad. That looks just as bad. Which is easier to do, a dot product or a cross product? Which is easier to do, a dot product or a cross product? A dot product. So you're trading two cross products for two dot products. A dot product, a scalar or a vector. A dot product, a scalar or a vector.
Scalar.
A scalar. How hard is that to calculate? How hard is that to calculate two times the vector 3, 1, 5? How hard is that to calculate? What is that? You better know. What is that? What is that? What vector would that be?
6, 2.
Yeah, 6, 2, 10. 6, 2, 10. So this is an easy product, and this is an easy product, and you can just subtract the two. And it's even better on a time test. You can leave it as a scalar times a vector minus a scalar times a vector. You've got the problem done. You've got the problem done at that point in time. Okay, last identity and then you're leaving. Last identity and then you're leaving. You're going to hate this one. You're like, oh, you got it. Now instead of three vectors we have 4. Dr. Warren, I just got to where I could visualize 3. Now I've got 4 vectors sitting in 3-dimensional space, and I want you to take the cross product of 2 of them and a cross product of the other 2, and then take the dot product of those. That's where you'd be like, I'm not doing it. I don't care. I'll lose my points. I'll take the loss. I'll lose the points. But this is equivalent to, and we could prove this. I asked you to show this. A dot C times B dot D. I'm trading cross products for dot products. I'm trading cross product minus A dot D. And what do you think the last term is going to be? What do you think the last term in this flashcard is going to be? If you had to guess, what the last term in the flashcard is going to be, B dot C. Now, seriously, which would you rather calculate? It this way or that way? It this way or that way? The first way or the second way? The second way. Okay, all of these are flashcards. I want your cross product flashcards done. I want your homework in 12.4 done, and I want you reading 12.5. Are we all on the same page? Whew, that was a long lecture. You guys are great. You're better than me. You have better attention spans than I do. You guys are great. I will see you on Friday. What do we have next Friday? Quest 2. The setup will be the exact same way as Quest 1. And that will be the last time it will be that way, I'm hoping, all semester long. That'll be the last time it'll be that way.
We still have 13 minutes.
I'm gonna do this every freaking time. I went over 15 minutes in my first class. And I've got to get it down. It's the fact that we're starting on Monday, Wednesday, Friday at these broken times, not our regular 8, 9, 9:05. Okay. Thank you. You guys are good. I would have exited like a lot of people did immediately. Okay. Stand up again. Sorry. Stretch. Okay, sit back down, sit back down. Turn to a nice white sheet of paper. Clean, completely clean sheet of paper. Nice, 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 nothing written on it. Let's see what you just memorized. Let's see what you just memorized. Okay, I give you 3 vectors on next Friday. I give you 3 vectors, and I ask you to calculate A cross B cross C. Write down what's an equivalent form, but much easier to actually calculate. Write down what's an equivalent form, but much easier to actually calculate. Okay, imagine that I give you 4 vectors. Imagine that I give you 4 vectors, and I ask you to calculate A cross B dot C cross D. Write down, what's an easier way to calculate this? What's an easier way to calculate this? Okay, go to grid view, go to grid view, go to grid view. Go to grid view, go to grid view, go to grid view. And hold up what you've got, hold up what you've got, hold up what you've got. Let's see what you've got on your papers. Let's see what you've got on your papers. Nice, Cosmo. Let's see, Bridget, what do you got? Nice, Gordon. Mason, can you hold yours up a little bit more? Oh, you're working on you're working on some tablet. That looks cool. Caitlin. Okay, good. Okay, make me number 1. Make me number 1. Make me number 1. Okay, everybody's hands on the space bar. Everybody's hands on the space bar. The first one. What's the first one?
A dot C dot C
Times B minus A dot B times C.
Notice the A gets dotted with both. The A gets dotted with both. Which A's outside here? This one. Everybody's hands on the space bar. Everybody's hands on the space bar. What if you got A cross B dot C cross D? What do you write down?
A dot C times B dot C minus A dot B times B dot C.
Perfect. Okay. And that will end our flashcards for the cross product. That'll end our flashcards for the cross product. There's a lot of them. Okay, now I'm gonna get your brains just something easy. Draw an XY axis. And plot the point 2, 3. Plot the point 2, 3. And plot the point 5, 8. Plot the point 5, 8. So draw yourself an XY axis. Draw yourself an XY axis and plot the point 2, 3 and plot the point 5, 8. Now draw the line that goes between those 2 points. Euclid said 2 points determine a line. Give me 2 points, you have a line. Okay, now let's make all of your high school teachers, starting in 7th grade up through 12th grade, proud of you, and find the equation of that line. Find the equation of that line. You've got a line, find the equation of that line. Put it in slope-intercept form. Put it in slope-intercept form. Now I'm talking like a good high school teacher. Put it in slope-intercept form. All right, what do you have? What do you have? Does anybody have it done? Does anybody have it done? Does anybody have it done? Does anybody have an equation of the line that runs between the points 2, 3, and 5, 8? Does anybody have an equation of the line that runs between the points 2, 3, and 5, 8? Were you asked to do this in high school? Were you asked to do this in high school more than once? More than once. Does anybody have the slope of the line? Does anybody have the slope of the line? Does anybody have the slope of the line? What number did you get for the slope of the line? What?
5/3.
5/3. Did anybody else get 5/3? Anybody else get 5/3? Okay, so we know it should be 5/3 x plus the y-intercept, plus the y-intercept. Did anybody get a y-intercept? Anybody get a y-intercept? Did anybody get a y-intercept?
Negative 1/3.
Negative 1/3. Now, most kids know how to do that, but they don't know how to do this. Explain what that means. What does this mean? Y equals 5/3 x plus negative 1/3. Explain what that means. You're like, well, Dr. Warren, it's the equation of the line. Why is it the equation of the line? And you're like, well, Dr. Warren, you get your 2 points and you get the slope and then you plug in the points and then you get your y-intercept. And that's why it's the equation of the line. But you don't ever really think about it abstractly enough to understand why it's the equation of the line. You don't understand because you're just going through a technique that teachers taught you. You're not really focusing on what does the equation of the line actually represent. And that's where you're screwed going to Calc 3. Especially when we're heading to lines and planes. What this really means and what they don't write down is that it's a set. So write down the letter S and give yourself 2 big braces for your set notation. This really means it's all the ordered pairs, all the points in the plane. It's all the points in the plane that satisfy the equation y equals 5/3 times x minus 1/3. That's why it's the equation of the line. It's all the points in the xy plane that satisfy y equals 5/3 x minus 1/3. Now I've got to ask, would this point satisfy that equation? Would this point be in the set S? Would the point 2, 3 be in the set X? Would the point 5, 8 be in the set S? Are there more than 2 points that would be in the set S? The collection of all of the points, and they just so happen to lie on this line, the collection of all of the points that satisfy this equation is the line. Now we're going to end with this. Imagine we jump up a dimension and we have something like y equals 5/3 x plus 2/5 z minus 1/3. And I ask, what are all the points in XYZ space that satisfy this equation? And you might be tempted to think it's a line, but it's not. It's a, can you guess? Can you guess? All the points that satisfy this equation, can you guess what it is? Can you guess what it is? If it's not a line, then it's probably in this section is going to be a plane. A plane. Well, that leaves the question, how do we get a line? How do we get the equation of a line? And we'll pick up with that on Friday. We'll pick up with that on Friday. Thanks for saving me yet again. Thanks for saving me yet again from quitting class 15 minutes early yet again. Okay, 12-4, 12-4, read 12-5, finish the homework. You have a WebAssign due when? You have a WebAssign due when? Friday. You have a WebAssign due Friday on 12-4, just like your homework, just like your homework. Okay, I will see you guys now. I will see you guys. Thanks for putting up with me. Thanks for putting up with me.
Thank you.
Thank you.
Thank you.
Thanks, guys. Oh, why did they put up with me? That's the question. Well, let me stop this before why did they put up with me?